Forever the journey is not done. In the world of education, they are the guiding sun. So let our voices rise and our hearts intertwine as we celebrate this learning shrine. In this seminar, together we stand, guiding the way hand in hand. A very warm good afternoon, ladies and gentlemen. Today I, Sarfaraz, on behalf of Department of Information Technology, feel highly privileged to award a warm and a cordial welcome to our galaxy of intellectuals, esteemed faculties, section in charges, starving students, and my fellow friends. Welcome to this enigmatic intellectual sphere, where artificial neural networks version and bestow unparalleled cognitive capabilities upon machines. As we delve deeper into this realm, the reverberation of the deep learning, a subset of machine learning and artificial intelligence, penetrates the intricate web of data, fostering a profound understanding of the digital cosmos. Let's raise our voices in resounding applause for the orchestrator of this remarkable event, whose meticulous planning and dedication have made this gathering an extraordinary success. Dr. Javed Mia, sir. Thank you, sir. Let's embark on this intellectual odyssey, where the amalgamation of innovation and algorithmic sophistication opens a new frontier of possibilities. Here we unravel the fabric of data, weave the tapestry of knowledge, and shape the counters of the future, where the unbounded potential of machines converges the limitless boundaries. So now put your hands together to embark today's proceedings. Ladies and gentlemen, it's our privilege to introduce today's distinguished seminar speaker, a visionary in their field, whose insights promise to enlighten and inspire us all. Dr. Sarfaraz Masood. Dr. Sarfaraz Masood is currently working as an associate professor in the Department of Computer Engineering, Faculty of Engineering and Technology, Jamia Millia Islamia, New Delhi, India. He has a rich experience in teaching and research for more than 16 years in the field of computer science and engineering. He has also worked in the software industry for around a year before joining academics. He has obtained his PhD degree in computer engineering with a focus on the field of artificial neural networks. His research areas include machine learning and deep learning applications in healthcare, vehicular safety, agriculture, etc. He has published more than 60 research papers in various reputed international journals and conferences in his research domain. He has been granted an international patent titled a feature-boosted web-based product purchase recommendation method and system. He is also serving as a technical expert in multiple committees at various government institutions in India, including UPSC and CESC UGC. Ladies and gentlemen, now I request Dr. Sarfaraz Masood to address the gathering and commence the program to inspire us to pursue our dreams and aspirations with passion and dedication. Over to you, sir.
Thanks a lot for this lovely warm welcome and this warm presence of everyone here. I'm really honored to be present here, to be talking with you people and sharing my some sort of experience with you people in this field, and with high hopes that you will take back something from this lecture. So how many of you are intrigued by this artificial neural network thing? सुनने में तो अच्छा लगता ही होगा सभी को ना? AI है ना? Neural networks. It works something like our brain. ये तो बताया जाता है? Everybody is comfortable in English over here? Yes. Yeah, correct. Perfect. So we're all having this idea that these neural networks, they work like our biological brains, and the way we perceive these networks can also perceive, which is why the most basic of the networks is called a perceptron, right? Can perceive. Okay, so without wasting much of a time, because I think we've already taken some sort of a time from this lecture, I'll move forward, and I think to have your attention to this session, I'll first start with this very small demo which I prepared here itself while the discussion was about to start. Right, so I hope this page is visible to everyone. Yes. within this very small amount of time that I got and I sat over here, I made my neural network, and that to a deep learning based neural network within this much small amount of time. Just to, I could have done that back home at my office, but just to tell you that this era, we have got this power on our laptops so easily, and within a very, very small amount of time, I can build something very particular to a particular problem. So see, I made a small network over here, and this network is actually classifying into 4 things. It's recognizing 4 things. First, me, I'm saying this is a class, hello, it is me. I hope I'm audible to everyone?
Yes,
Yes.
sir.
The second one is saying I'm not here, so you can see it's having frames where I'm not present within this video. The next one is I'm just showing my right hand. Somebody might have seen that while I was doing the recording. And the last of the class is just capturing my left fractured hand. So let's see what happens if I start taking it. So I'm just using the webcam of my laptop. So that the same thing I use to record and the same thing I'm using to test. So you can see my content is coming over there as a webcam content, and you can see which class it's showing right now. I'm not in the frame, and which class it's showing. I'm not there. Now if I come, it immediately recognizes that I'm here, right? If I bring my hand, which class is getting the most probability?
My right hand.
That's smart. My right hand. And if I bring my left hand in front of it, no matter what angle or orientation I take, the more amount of data I present on that pertaining thing, it recognizes. So it's so very easy, it's so very simple these days to build a problem, to build a model for a problem. So if you have your problem with you, you can build these models so quickly. So this was just a demo to show you that what kind of power we do have. I'll come back to this demo session once again towards the end of my discussion. Let me move on to something more academic. Let me come to my presentation. So this is about applications of deep learning in healthcare. So how many of you are comfortable with deep learning? How many of you have done some sort of a course or done something in deep learning? Not many. Okay, right, 3, 4, great. So others are the ones whom I'm actually interested in. So what do you think is deep learning? I think let this be very, very interactive. Even if you're wrong, let things come from your side. That will make things a bit more interesting. Otherwise, I'll just keep on speaking, you will listen, and it will be a one-way broadcast radio conversation, which I don't want. So what is deep learning? What do you think its form? Anyone? Okay, what is learning? Let's come to a very basic thing. What is learning? If you say you've learned to ride a cycle, what do you mean by that? I'll not come to you. Anyone else? Anyone else? What is learning? यार कहते हो मैं सीख गया. Learning वाला हिंदी में कहते हैं सीख गया. What do you mean by सीख गया? क्या आपका वजन बढ़ा था? क्या आपकी हाइट बढ़ गई थी? Right? क्या आपका brain mass बढ़ गया था? What happened? If you say that a boy or a child has learned to write alphabet A within that one day of time, so एक दिन में ना उसका weight कुछ खास बढ़ा होगा, ना उसकी height बढ़ी होगी, तो what measurable thing happened? What change happened? What do you say कि learning हुई है? How do you define learning? अगर आप कहते हो कि मैं कुछ चीज सीख गया हूँ, सीख गई हूँ, तो इससे क्या मतलब हुआ? Anything? So anyone? बताओ तुम. You can say. हाँ, बोलो.
So there is a term known as paradigm. Patterns होते हैं. तो ये training
Simple रखेंगे यार.
से instructions होती है तो हमारा दिमाग जान लेता है कि यार ये है.
Okay. देखो, लर्निंग का मतलब होता है कि अननोन पर भी रिस्पॉन्ड करना सीखना, राइट? आपको जिस किताब से अल्फाबेट्स पढ़ाए गए थे, आपने वहां से पढ़ लिए. अब आपको एक अननोन, you get a sample from an unknown domain, same alphabet series, but even that you recognize. Okay? Teacher were teaching you some math subject, some math concepts, and he or she asked you some questions on that particular. Let's say factorization. So some questions were taught you in the class about factorization. आपने वो क्लास वाले क्वेश्चन कर लिए, ठीक? अब अगर मुझे टेस्ट करना है आपको कि आपने वाकई सीखा है नहीं सीखा, should I give you the same question or something different from the same domain? Something different from the same domain. So when I get responses from your side on something similar but not same, and those responses are right, I say that you have learned. So the ability to respond to an unknown stimulus is called learning in a desired way. In a desired way. Seeing a P and calling it an A is not learning. Getting a question for factorization and you're doing a summation over there is not learning. So giving a desired response on an input that you may have seen in a similar sense but not the same, that is called learning. And what happens within you? आपके जो brain के neurons हैं, they have connections. That's called synapses. They tend to get stronger or weaker. Okay? 5 साल की उम्र तक बच्चों के न्यूरॉन्स बन जाते हैं, बॉर्नवीटा वाले को बताते हैं बात. And that happens. Most of the neurons they develop by the age of 5, 6 or 8. Then what happens? Why do you become wiser after 18? The connections between those neurons they become strong. Two cities, they want to communicate. If the roads between those cities are very narrow, they can't communicate well. They can't interact. But if two cities, they have very broad highways among them, they can communicate well, isn't it? So two cities, how prosperous they are. If they want to communicate, if they want to build a stronger relationship, what should be the best between them? The connection roads. Same goes with you. Your neurons, they were developed by the age of 7, 8. But you can't be wiser because wise things come from decision making. And decision making can only happen when the neurons, they are interacting well among each other. So what do you do by practicing and practicing and practicing again and again kind of questions? You are actually trying to make some bond between your neurons as strong. And what happens when you start going beyond the age of 60? Your biological process comes into picture and the neurons, their connection, they tend to die. The lesser you practice a topic, the neurons that have got a stronger connection during that practice time, वो सब connections weak होने लगते हैं. और आपको लगता है यार पहली बार कई सालों बाद साइकिल चलाओ तो ये ठीक लगता है. क्यों? क्योंकि वो न्यूरॉन जो बैलेंस बना रहे थे, वो न्यूरॉन्स आपको इनपुट दे रहे थे, वो सब अपनी जगह तो है, but they are not communicating well. So the communication channel between neurons has to be strong. तो artificial neural network जो है, वो biological neural network का inspiration है. And my professor taught me a very beautiful thing which I remember it and I discuss every time with my students. कि biological neural network और artificial neural network में वही connection है, वही relation है जो bird और aeroplane में. They ultimately do the similar thing. दोनों उड़ते हैं, but दोनों का mechanism अलग है. Inspiration नहीं है. ठीक है, ऐसा नहीं कह सकते कि adaptation है proper. Biological neural networks का adaptation नहीं है artificial neural network. हाँ, we can call them in a sense कि they are inspired because end result वैसा ही आ रहा है. But the way biological neural networks work and the way artificial neural networks work, they are a bit different. So what are ANNs? ANNs are actually networks of fundamental processing units called neurons. एक बड़ा सा network है, okay, जिसमें छोटे-छोटे elements हैं neurons. वो आपको कुछ processing कर सकते हैं. They can do some computations. वहाँ डिफाइन किया हुआ मैथमेटिकल कंप्यूटेशन आप क्या करोगे और एक न्यूरॉन कंप्यूटेशन करने के बाद सेकंड न्यूरॉन को डेटा भेज देता है. दिस थिंग कीप्स ऑन रिपीटिंग इन अ नेटवर्क प्रोसेस लाइक दिस. ये पहला इफ समबडी ओवर हियर हैज अ प्रॉब्लम कैन कम टू दिस साइड. ये एक न्यूरल नेटवर्क है, आर्टिफिशियल न्यूरल नेटवर्क. फीड फॉरवर्ड, यहाँ इनपुट लेयर है दैट्स टेकिंग द डेटा, प्रोसेसिंग द डेटा एंड पासिंग ऑन टू द सब्सिक्वेंट लेयर. This is called the output layer from where I expect my output to come. Output can be a number, output can be a class. So my neural networks can do regression. I hope everybody knows what's a regression problem. Finding a salary, finding the age, finding today's temperature is a regression problem. It's a number on a very big number line. Out of infinite options, you are trying to give me one option. That's a regression problem. But the other type of problem is called a classification problem. Today's weather is bad, worse, good, moderate, excellent. You have divided the entire thing into ranges, 5 categories. So if you have your output in the form of categories, the problem is classification. If your output is in the form of numbers, then it's a regression problem. My neural networks can work for both. They can be trained for regression problem, they can be trained for classification problem. The demo that I showed you in the beginning of this session, it was a classification problem because my network was about to generate 4 outputs. So this is a kind of a mesh network. Each neuron is doing some, I'm sorry, it's a bit more like speaking some. So each neuron is actually doing a computation and whatever output it gets, it passes on to every other neuron which it has a connection with.
Same thing happens with your brains also. Something similar happens. Your neuron, it gets some input. आपके दिमाग के विजुअल, आपके दिमाग में अलग-अलग सेक्शंस बने हुए हैं. विजन का सेक्शन अलग है, लैंग्वेज का सेक्शन अलग है, मेमोरी का सेक्शन अलग है. Right? You've got lobes within your brain. This is called a decentralized architecture. इसके benefits हैं. What are the benefits? अगर सब कुछ एक ही कंप्यूटर करेगा, पूरे यूनिवर्सिटी का डेटा एक ही कंप्यूटर पे होगा, if that goes down, what happens? The entire system goes down. That's the problem with the centralized behavior. But if you have 10, 15, 20 different nodes where computations are happening, then even if one of the section goes down, the other sections are still, they're working. Movies में दिखाते हैं यहाँ चोट लगी थी, memory चली गई, बाकी सब चल रहा है. Vision चल रहा है, language चल रहा है, senses चल रहे हैं. Right? तो ऊपर वाले बनाने के तरीके में बहुत बड़ा point था. कि साहब कहीं एक जगह चोट लगेगी तो वो organ खराब, वो section खराब होगा, पूरा system बंद नहीं होगा. It's a very fault tolerant situation. Same goes here. आपके न्यूरल नेटवर्क में कोई 2-4 न्यूरॉन काम नहीं कर रहे, न्यूरल नेटवर्क बहुत रोबस्ट है, बाकी न्यूरॉन्स they will start taking care of that. So something similar that happens in your biological neurons, similar behaviors have been observed in artificial neurons also. This is also a network of processing nodes called neurons. This is also a network of processing nodes called neurons. My brain or your brain, it does something beautiful that's called decision making. Same thing can happen here also. But the decision making can only happen on the basis of these network, these connections getting strong or weak. If you want to take a decision, your connection between the nodes should be strong or should be weak. So till the time of 90s, early 2000, this was the way people were doing research. Industries were doing research this way. Why? I mean, how? So if I have an input, if I have a data, then till the early 2000 or late 90s, people were actually extracting features because my neural networks are mathematical models. I gave input from my camera, so those inputs were actually images. So it seemed as if the neural network is working on images. But no, neural networks can't work on images. You talk to Siri, right? Or Cortana, that's the other thing, yeah. So you talk to those softwares and you say something, Alexa, you say something. It seems as if the software is listening to my voice. It is, but it's not working on the voice. Okay, so what they're doing, they take the input, they convert them to numbers because neural networks can only work in numbers. It's a mathematical model. It will need numbers. So what people were doing, they take the input, they process that input, they convert that input into numbers, and those numbers we call features. So we say that, metaphorically, my image has features. And if I give the right features to my classifier can do the classification. So neural network was here, was doing classification. Give the network the right set of inputs, it will do the classification. So this part was very important. You are the system, let's say, and you have to take decisions. But if you're not fed well, आपको सही खाना ना दिया जाए, आपको सही nutrition ना दिया जाए, क्या system काम करेगा? नहीं. So if your nutrition is not good, आप कितने ही अच्छे कॉलेज में क्यों ना हो, आप कितने ही अच्छे environment में क्यों ना हो, you will not learn. Your nutrition has to be good. ये problem था यहाँ पर कि अगर मैंने बहुत अच्छा न्यूरल नेटवर्क भी डिजाइन कर लिया, लेकिन मेरा जो डेटा है न्यूरल नेटवर्क वो अच्छा नहीं है, that is not good. So the network will not give results that you are expecting. So deep learning ने क्या चेंज किया? So deep learning ने क्या चेंज किया? What we find, paradigm change जो हमें नजर आता है, वो ये हुआ कि साहब, they said कि अब आपको फीचर निकालने की जरूरत नहीं है. You don't need to do feature engineering. The network was doing classification. They said the network can also extract features for you. You give the data to the network will do feature extraction, the network will also do classification and will give you the result. So this part was replaced by a trainable feature extractor. The word trainable means you can train this part. Give the right input, tell what output should be produced, and it will try to train. Okay, I'll give you an example. Tell me what mathematical function I'm talking about. the input is 2 and the output is 4. The input is 3, the output is 9. What mathematical function I'm talking about? Square. My God, everybody is bang on. Square. कैसे predict किया आपने square? By looking at the numbers on the target and the input side. है ना? You did a mapping ना? दिमाग में mapping किया कि 2 मिलने पर 4 मिल रहा है, 3 मिलने पर 9 मिल रहा है. तो आपने एक approximation किया. क्या किया आपने? Approximation. You did an approximation. That's called function approximation. Neural networks are function approximation. Function approximators. They approximate a function. So आप सही इनपुट और सही टारगेट बताओ. न्यूरल नेटवर्क पता लगा लेगा अपने आप कि क्या फीचर होंगे जो उस आउटपुट को जनरेट करेंगे और वो क्या वैल्यूज होंगी जिनसे क्लासिफिकेशन हो जाएगा. So they are so powerful. इसी वजह से आज के डेट में काफी डिबेट भी है. जैसे they will beat up our jobs, they are getting very smart, but there are some points where they don't work so smart. So पुराना जो स्ट्रक्चर था वो ये था कि आप फीचर इंजीनियरिंग कीजिए, न्यूरल नेटवर्क क्लासिफायर बना देगा. The new domain or the new way of working is this: you give the inputs, the network will extract features, the network will perform classification, and will give you the right output. What I did in the example, in the demo, I just gave my image samples to the network. The network trained, it had 2 components: feature extractor, classifier. 2 components. Remember, every deep learning model will have 2 components, major components. Feature extractor and a classifier. The feature extractor will extract features and will feed to the classifier. The classifier will take those features and will perform classification. Okay, I have an image. In that image, I have extracted some features. Now tell me what animal am I talking about? The features are, the animal has a small tail, 2 big ears, big body, 4 big legs, and a big long snout. What animal am I talking about? Elephant. I'm talking about an elephant. So if I extract the right set of features from the image, my neural network can perform classification. वो आसानी से classification कर सकता है. This was a work done in 1998 by a famous researcher, Jan LeCun, and these people are still alive. CS researchers are still around the corner. So this work was actually recognition of handwritten digits. This dataset is called an MNIST dataset, and Jan LeCun proposed a network for the first time in 1990. It was a very famous paper and actually laid birth to the development of convolutional neural network. And his model was a very simple model and was able to distinguish very clearly what data am I talking about. And even though I had some tarnished image given, even then the model was recognizing what data is there in this image. Since then, a lot of things have changed. What has changed? My data. Earlier, data was only image initially for my deep learning networks. But now we know we can do deep learning on signals. Signals can be audio, signals can be your EEGs, your ECGs, physiological signals. Your signals can be, your data can be text, your data can be visual, it can be videos also, continuous stream. A lot of type of data can be given. So since 1990s, the way the data is being fed to these deep learning net models is getting changed quite a lot. What has significantly changed also is the hardware. Now almost everyone can have a 6 GB graphics card on their laptop itself. In 2012, a very famous paper was written by Alex Bizersky. That model is called the AlexNet. And at that time in 2012, they did not even have a GPU more than 3 GB. So they had to train their model on 2 different machines that have 3 GB GPU. And now on this laptop itself, on which I'm communicating you through, this itself has a 6 GB GPU. So definitely the progression in the GPUs has been propelled quite heavily. And what has changed during the last decade is the algorithm that we are using. A number of new algorithms have been proposed and they have been proven to work efficiently well. If people working in deep learning, they might have heard of algorithms like Inception, BGG, ResNet, so on and so forth, wherein they have been applied. Deep learning models have been applied on images, they have been applied on text summarization, text recognition, Alexa, Siri, Cortana, they're all the examples. They have been applied on audio, they have been applied in games. We now have chess grandmasters getting beaten by AI-based agents actually. So as I said, this lecture is more about convolutional neural network or deep learning. I'll just give you a hint about what the structure of a deep learning model looks like. You will find 4 components in a deep learning model. One of them is called a convolution operation. The other one is called pooling operation. The next one is called a flattening, and the last one is actually a fully connected layer. This is the architecture that Jan LeCun proposed, and this is what he said, that input data will be scanned to find features, and ultimately after multiple scanning, you will have a list of features, and your classifier from the list of features can distinguish whether the image has a face, has a dog, or has any other object. So that kind of classification can be done. I won't go deeper into this mathematics, but this is what a convolution operation looks like. If you observe carefully, this is a beautiful scanning that is happening. What do you want? You want features from your image. And how can you extract features? Scanning. So you have a small, okay, let's say you are a detective. So what is the most famous tool that you find with every detective? A magnifying glass. So if I have, let's say, a page in which I need to find features, what will I, as a detective, do? I'll scan. I'll scan. So what should be my right way of scanning? Left to right, top to bottom. Look carefully what is happening here. Left to right, top to bottom. Logic है भाई हर चीज पे. Intuition पे जाओ. जैसा हम लोग कर. What is a computer algorithm? It's a mimic of how we would do the same thing. What is binary search? आप लोग तो CS और IT के लोग. Binary search पता है? Binary search. What is binary search? Searching in a book. We have been doing that since our second and third. समझ में आ गया था क्या किताब नंबर्ड होती है. If I have to find a page, I'll simply blindly open the book from the center. And if my page is lesser than that, I'll go to the left. If my page is greater than the center, I'll go to the right. So it's a simple adaptation of how humans would solve the problem. So how will I find a feature from a text? I'll scan. So I have something called a filter. This filter is my magnifying glass. This is my data. And on this data, I use this magnifying glass. And this magnifying glass will actually find one type of feature. Wherever it finds that feature, or whatever feature it finds, it registers that in another slip. This slip is called a feature map. नाम में काम जाहिर. Feature map, a map of features. ये filter, ये magnifying glass, जब इस image के ऊपर चलाया गया, it found these features. Right? So I had a big organization of detectives. Layer 1, वो micro features ढूंढते हैं. वो अपनी रिपोर्ट बना के क्या करते हैं? सीनियर को दे देते हैं. सीनियर क्या करेगा? उनकी रिपोर्ट लेगा और फिर अपना और बेटर वाला मैग्नीफाइंग ग्लास लेके उनमें से फर्दर फीचर निकालेगा. वो अपनी रिपोर्ट बनाकर अपने सीनियर को देगा. So on and so forth. क्या होगा? A time will come after multiple layers of scanning, you will have the right set of features with you. This operation is called convolution. I won't go into trivia. That's much understood. I will share these slides so that will take help. Otherwise, these have been prepared from some well-known public open resources only. Just look at the operation in 3D. This is how it happens. Why? Because my images are 3D. Now you will say, sir, image to 2D hoti hai. How is it 3D? It's actually a layer of red, green, and blue together, which shows you color. It's an RGB component. So 1, 2, and 3. R, G, and B. So my images are 3-dimensional. It's not 2-dimensional. And once a filter is applied, you can see a feature map is produced. This feature map is actually the list of features that were found out from this image. This is given to the next layer. अब आप इसमें और feature ढूंढ लीजिए भाई. मैंने तो ढूंढ लिए. अब आप मेरे senior हैं, आपके पास अच्छे filters हैं, आप इसमें और ढूंढ लीजिए और minutely देख लीजिए. So a time will come after multiple of these stackings, you will have a last layer which will produce the last set of features. सारे features मिल जाएंगे उसको. जो क्या चाहिए feature? Image में से मुझे क्या मालूम करना था? उसके legs कैसे हैं animal के, उसका फेस कैसा है, उसके ईयर कैसे हैं. शेर के ईयर छोटे होंगे, टेल बड़ी होगी, बॉडी छोटी होगी, बट उसका जो हेड स्ट्रक्चर होगा वो थोड़ा सा पावरफुल होगा, मेन होगी उसके अराउंड. एलिफेंट में ऐसा नहीं होगा, रैबिट में ऐसा नहीं होगा. सो यू जस्ट टेल मी दोस फीचर्स दैट विल डिस्टिंग्विश दिस ऑब्जेक्ट फ्रॉम द अदर वन. तो सबसे पहले वाली जो लेयर्स है बहुत बारीक बारीक देखती है, छोटी छोटी चीज देखती है. उसके बाद वाली लेयर थोड़ी और बड़ी चीज देखती है, उसके बाद वाली लेयर और बड़ी चीजें देखेंगी, और अल्टीमेटली वो फीचर्स मिल जाते हैं जिससे कि आपको मालूम चल जाएगा उस इमेज में क्या रखा हुआ है. जस्ट टू शो यू दैट. So after convolution, that is finding out the features from the image, we apply something called pooling. Pooling is actually aggregation of features. कि आपके पास जो features आए थे, उनमें से आप जो best possible feature है, उसको आगे भेजो, जो हल्के features हैं, उनको छोड़ दो. So it's actually downsampling the image. तो आपका जो content है, उसमें जो most important feature था, वो हमने आगे propose किया, बाकी वाले content को हमने रोक दिया. तो यहाँ पर इस सब unit के अंदर 3 सबसे important feature था that has been sent forward. This is the structure of the LeanIt. The next architecture that was proposed after 1998, the bigger achievement came in 2012, almost like 14 years later, because there were technological restrictions. So AlexNet was a very big achievement in 2012. It was a very deep network. You can see from the image till the last layer, a lot of layers are there. So it's a very deep network. This had almost 8 layers, and if you can see this number, I don't know how much it's visible. This is the number of parameters that this network has. Your AlexNet has almost 62 million parameters, so that's a very big number. And जितने ज़्यादा आपके पास parameters होंगे मॉडल में, उतना ज़्यादा मॉडल complex होगा. So these days we are actually trying to reduce that. Just to show you the graphics, look at this table, please. AlexNet, this is the result obtained by applying simple ANNs. This is a challenge called ImageNet Large Scale Visual Recognition Challenge, ILS-VRC. In 2010, a shallow model, 1 or 2 layer model was applied. The error percentage it got was 28.2. So error between what was expected and what was observed, target minus observed, that was 28.2. This got reduced to a bit in 2011, 25.8. But these networks were shallow networks, 1 layer, 2 layer, 3 layer networks. Then came AlexNet. AlexNet had 8 layers, and this gave a remarkable reduction in the error percentage, which came down to 16.4. So AlexNet was definitely doing something better. This was further up improved to 11.7. And if you look closely, this graph goes down to 3.57. The error has gone down from 28.2 to 3.57 by a recent network called ResNet. That's a residual network. आजकल के वक्त का बहुत ही famous network है, and we use this network quite a lot. But you can see the network now has 152 layers. You started from a 2-layer neural network, और आज की डेट में हम कितने layers की बात कर रहे हैं? 152. So 1, 2, 3, 4 up till 152. That's why it's called a deep network. Deep learning. Because the networks that these structures have, they are very, very deep. और ये सारे के सारे जो layers हैं वो sequential हैं, एक के बाद एक रखे हुए हैं. तो आपके image को output generate करने में 152 layers होकर गुजरना पड़ेगा. ये thumb rule है, आप जितने ज़्यादा protocols होकर गुजरोगे उतना टाइम लगेगा. बट जाहिर सी बात है फिल्ट्रेशन यहाँ पर बहुत अच्छा होगा, बिकॉज ऑफ विच जो फीचर्स ये नेटवर्क निकालता है वो बहुत ज़्यादा प्रिसाइज होते हैं एज कम्पेयर टू द फीचर्स जनरेटेड बाय अ शैलो नेटवर्क. बेटर द फीचर्स दैट यू एक्सट्रैक्ट, द बेटर रिजल्ट्स यू विल जनरेट. Other networks were ZFNet. ZFNet was the person, again was an 8-layer network. Then came another famous deep learning model called the VGG network, that's Visual Graphics Group. Oxford University had this research group which proposed in 2014 the first VGG network. The intuition behind this VGG network was different from the one followed earlier. Structure was also a bit different. Earlier, the structure was find out the filters, reduce the filters. Find out the filters, reduce the filters. In other words, convolution layer के बाद pooling layer, फिर convolution layer, फिर pooling layer, फिर convolution layer, फिर pooling layer. This was the structure that was normally getting followed till 2013. They changed this idea. They said no, you find out the filters, you refine the filters, and then you reduce them. Don't reduce heavily. So pooling layer, it tries to reduce the layers, reduce the features. So they said do not reduce the features. Apply a convolution, that is extract features, then extract further fine-grained features, then reduce. So stacked convolution concept came here. So a stacking of convolution operation came to the picture. And as you can see, the layers have raised from 8 to 19. This was which is 16 to 16 layers, and the parameters of the model have been increased to 138 million. 62 million से बढ़कर 138 million parameters हो गए. Thumb rule वही है. More the number of parameters you have in the model, the more complex the model will be. But more refined features you will get. इसी को VGG ने और improve किया इसी साल, and they produced another paper that was called VGG 19. This model had 19 layers, so from 8 to 16 to 19, and the 19 layer network had more number of convolutions, so more detailed features were getting extracted. But these parameters, they raised to 165 million. But the error was going down. The error was going down. That was the bigger thing. So people realize, यार ऐसा लग रहा है कि the more layers I increase in my model, the better my model will perform. So people started running towards increasing the layers with some intuition. Then came another famous network by Google, and this was called the Google Net. They did not name it Inception, but later on this was known as, or it became infamous by the term Inception. You have seen a movie called Inception? Leonardo DiCaprio?
Yes.
वहाँ पे क्या फंडा है? It's a dream within a dream within a dream within a dream, right? So people realize this Google Net is actually a network within a network within a network within a network. So they famously start calling this as Inception. So Inception model, just to summarize, from 16 to 19 to 22, Inception model now had 22 layers. The number of layers increased, but they did something smart, and they tried to control the number of trainable parameters in the model. Their parameters reduced to 5 million. From 62 million of AlexNet, they reduced to only 5 million. So they were considerably less. So their model was very lightweight, even though it had more number of layers. And this is what their model looked like. Such a complex structure, but this was a repeated structure almost, so not a problem. And this graph that you're seeing over here, it's again a cascading of convolution and pooling and convolution and pooling. So by convolution I mean feature extraction, by pooling I mean feature reduction. So pooling means just keeping the maximum features with me and leaving out the minimum features. So then people realize, can we go further? 19 हो गया, 22 layers हो गया, जितना layer बढ़ रहा है deep model में उतना ज़्यादा result अच्छा आ रहा है, क्या हम और ज़्यादा deep जा सकते हैं इस network के अंदर? So people started exploring, and they came up with another network that's called residual network, ResNet. और इस network का structure थोड़ा सा ऐसा था, जहाँ पर इन्होंने skip connections include किए थे. You can see those hopping connections in the network. It's again a series of convolution, convolution, convolution and pooling. Same फंडा लग रहा है, but यहाँ पर उन्होंने थोड़ा सा connection का तरीका बदला. ऐसा connection करने से इनका network ज़्यादा deep बन पाया. Okay. Have you seen that meme जहाँ पर कहते साहब कि गवर्नमेंट ने तो बहुत सारा पैसा रिलीज किया, then it went to the bureaucrat, and then it went to the local नेता, then it went to another MLA, and then it went to the end user है जो actually लगता है उसके बाद peanuts पहुँच रहे हैं. So what was happening at each layer, something was getting taken out from the data. तो आपका डेटा जो लास्ट लेयर पे पहुँच रहा है, जहाँ पर पहुँचना चाहिए था, वहाँ पर हो जाते थे बहुत मिनिमम हो जाता था. There is nothing relevant left in the data. So because every layer of your operation is actually changing your input, is actually changing, continuously changing. So इतना ज़्यादा आपका data change हो जाता है कि last layer तक कुछ बचता नहीं है. So what they did, they started infusing the data once again into the network. You can see the infusing happening. This is an infusion. After 2 operations, infuse the data again. After 2 operations, infuse the data again. It's like the government is saying that after every layer the amount passes through, we'll check the data again. If it's not, we'll try to fill up the data once again. So by the time it reaches the end user, the data will still be quite a lot intact. So that was the idea. Because of this remarkable idea of refeeding the data into the network, the model now could go up to 152 layers. And even people are going beyond that. And this is where things got interesting. So we got an error of almost 3.6% as compared to others that we get. So far I've just discussed with you what is called deep learning, and in deep learning a special type of network that's called convolutional neural network. It's comprised of 2 parts, feature extractor and feature
classifier. They can be applied in a number of domains. Image processing में लगा सकते हैं, audio processing में लगा सकते हैं, signal processing में लगा सकते हैं, video processing में लगा सकते हैं. In any kind of data it can be applied. Either you can ask the model to do a regression, एक नंबर ढूंढ के बता दो, age, salary, कल का temperature, कोविड से होने वाली डेथ काउंट भी लोगों ने प्रेडिक्ट की है, because it's a number and neural networks are meant for those classifications. And then people started using it for those other applications also. So let's just restrict ourselves to healthcare. So deep learning can be tremendously applied to your healthcare section. It can be applied to neurological data. It can be applied to physiological data. It can be applied for medical diagnostics, heavy usage over there. It can be applied in bioinformatics, and it is being applied in therapeutic applications as well. Recently, a student of mine did this work where we had non-invasive sensor data taken from a patient, from a subject, and on the basis of that SpO2, heart rate, and a couple of more data that can be taken very easily by even our smartwatches. So that non-invasive data, by the help of that, the model was being asked to test whether the person is under any kind of stress, and the stress had categories: emotional stress, physical stress, or other kind of stress were being defined. So there were 5-6 categories within which the model was trying to do. Something similar which your smartwatches these days are trying. Right? They are trying to collect data, and within that smartwatch they have a small model fed, and that model, by taking the data from your samples, from your situations, it can predict the current situation of yours. Are you under any kind of a stress, whether physical or emotional or any other kind of mental stress? That kind of detection can be done. Then we also have neurological disease detection, Parkinson's disease, autism, ASD, autism spectral disorder, schizophrenia. So many neurological diseases can be detected. Now, Parkinson is a problem that affects our motor nerves, and we tend to lose our control over our motor nerves. And you might have seen people suffering from Parkinson. They have those shaky hands, right? And they tend to walk in a very small step because they don't have good control over their motor nerves. So these diseases like Parkinson, like dementia, if they are detected early, they can be managed. We don't have cure for them at present, but the earlier you detect, the better you can give a management. So people are doing autism detection, people are doing Parkinson's disease detection. Parkinson people, they have a change in their vocal cords also. So their vocal cords are affected, their motor nerves are affected, so their hands, they tremble. So people are trying to capture data in different ways. You give a person to draw something circular, any healthy person can draw that circle quite easily, but a Parkinson's patient cannot draw that easily. So people are collecting data of drawing certain shapes, and on the basis of the shape that you draw, a model can easily detect whether you have the initial stage of Parkinson or not. Dementia can be detected, schizophrenia. There are many such diseases that people are trying with the help of these deep learning models. Physiological signals, your EEG, your ECG, your polysomnograph, your sleep disorders. People are using heavily these models for those kind of detections. If you have any kind of a sleep problem, you don't need a medical person to be with you. You simply add a device to your sleep routine that will collect your data, give it to a model the other day, and this will do your detection whether you have any sleep disorder or not. And a couple of my students actually, they also did something in sleep disorder detection. Then medical diagnostic, having chest X-ray and you're doing whether it has a pneumonia or not. People during the time of COVID, they applied these models heavily. I mean, we've got lakhs of papers where people got applications of deep learning in chest X-ray detection. So the models are so sophisticated that they can distinguish between a viral pneumonia, a bacterial pneumonia, and a COVID pneumonia. 3 different types. And a deep learning model, once trained well, I'll show you the example at the end of this session, where just with the help of 300 samples, the model is doing remarkable decisions. And why I'm saying that, you will come to know at the end of this session. Then therapeutic applications also, your drug designing, there also deep learning models are helping. So one thing we realized that medical data has a big problem, that the data type is of high variety. We've got blood samples, right? And data is collected from blood samples also. Those are numbers. My sugar level, my erythrocytes, my TNC count, sugar values, all those pathological data, that's of numbers type. We have signals, we have got imaging, MRI, CT scan, DICOM images, we've got genomic data, okay, where our genes are expressed. Then we've got those vital signs, devices are getting included, which are producing those signals and collecting those samples non-invasive way. Then our phone is also collecting data for us. You will be surprised to know that people are predicting Parkinson's disease just with the help of our mobile phones. Our mobile phones have accelerometers, right? They've got those accelerometers, and by the help of these accelerometers, we can know the way you walk, your walking pattern. People can be distinguished. You can make a very small deep learning model on the basis of your gait patterns that can be related to your accelerometers, and it can recognize, if kept in somebody's pocket, whether this walking pattern is of the person who owns the mobile phone or not. So the way you train your model with your fingerprint scans, right, to tell the model that I am the owner and this is my scan, so nobody else can use this. But what if somebody has just taken my phone or without my permission and just walking away with my phone? So the phone can realize the person who is there with the phone right now is not the person who is supposed to be. So I'll first have to train my model. My model will collect some data of my walking pattern. A few of those walking patterns can be collected, and then it can recognize. The walking pattern of a person having a disease is slightly different than a walking pattern of a healthy person. And that can be very easily collected by a mobile. So mobile phones are collecting your data, and that can be used in a number of ways. This gait pattern thing was also used in one of the MI movies, Mission Impossible movies, right? Where the person was trying to mimic the gait pattern. It was loaded into the system. So really remarkable things are coming up. How deep learning can help in healthcare? A number of ways. Diagnostic. It can improve the diagnosis and prognosis, and thereby helping in reducing the risk. It can optimize the hospital process. So if you diagnose the disease, for example, a recent work we also had, and you can also find that on the internet, people are trying to detect whether a person has a COVID or not by the sound of the cough that person has. So let's say a couple of or 10 or 15 patients are waiting for a doctor, okay, in a waiting room. Even if I have a camera, that camera might not be able to predict the difference between a cough of a COVID person and a cough of a normal person. But imagine I have a sound recorder kept over there, and I'm taking the sound samples, and somebody is coughing, and on the basis of that cough I can recognize, and the authors made a very good model, and it was working quite efficiently. So they diligently recorded the samples of healthy subjects, people suffering from normal cough, people suffering from bacterial cough, and people suffering from COVID cough. So they recorded diligently their sound samples. They trained a model, and they kept it within the hospital. They kept it within the hospital, and it was taking the samples from the waiting area. So the moment they realized that they have a COVID subject, they immediately sent people over there to isolate that person from the rest of the public. That's the best way to do it. Or to show some urgency with that person. So somebody is coughing. What kind of cough is it? How can I take it so leniently? Because COVID is affecting our lives, even if at this point of time it is consistent. Identify patients, subgroups for personalized and precise healthcare. Reduce medication errors. Yes, COVID can, these models can help you. So one thing very clear about this, these deep learning models and these things are at the present scenario. They are not here to compete with the doctors. They are here to assist the doctor. They're here to help the healthcare system. So it's actually a complementary thing, not a competing thing. Although I'll show you a screenshot very soon where Jeffrey Hinton himself and Andrew Ng himself have said something very clearly, which you will find in the next slide instead. The first branch of medicine or hospital diagnosis that is getting under the attack is those of the radiologists. What do the radiologists do? They see your X-rays and they prepare a report. What did they find? They see your MRI, they prepare a report. They see your blood sample values and they prepare a report. So radiologists are the ones who prepare a report based on the report. And at the present state of the art models, these deep learning models, they are doing way beyond what an average radiologist can do. Getting numbers way beyond what the average radiologist can do. So detection of problems or absence of a disease, detection from a radiograph, they are actually doing much better. So they're saying people should stop training radiologists now. That's statement of Jeffrey Hinton. Who is Jeffrey Hinton? The person who himself gave the famous backpropagation algorithm. He's the one behind Google Brain. He's right now, he was earlier in Toronto University, but I think he has shifted now. So he's actually the father of the modern day neural networks that we see. He's the one who gave that famous backpropagation algorithm in 1986, because of which this revolution has come. So he's saying that no need to train radiologists anymore. You don't need that, because your deep learning models can do way better than what these radiologists right now can do. Just to show you the first example, this was a paper written in 2017. It's a very renowned journal, source where this paper was published. It had radiographs of healthy people and people suffering from diseases. These classes, so many classes you can see: pneumothorax, effusion, pleural effusion, constriction of your lungs. So these are all problems that you can see with your lungs. So
what they did a study. They gave these things to radiologists, 4 radiologists, well-known radiologists within those hospitals, and this was their performance. That almost 38, somebody had a 38% performance, somebody had a 44%. So the best radiologist gave was a 44% performance. So average of these radiologists came out to be 38%. And once the deep learning model was trained for all these classes, the model that they proposed within that first short they study was giving 43% accuracy. So this was way beyond the average radiologist can do. Now how it can help in Indian scenario? Everywhere we don't find, like India have many remote areas, villages. So one thing is very sure, now mobile phone is everywhere. Internet connectivity is also almost everywhere. So if we don't have is a good medical facility, so what we can do, somebody is, let's say, having some sort of a problem that can be diagnosed through a mobile phone, maybe taken. Recently we had a discussion with ICMR, Agra section, and they were saying that we have people from villages coming up for this problem of leprosy, right? That's a skin lesion disease, leprosy, जिसको हिंदी में कोढ़ भी कहा जाता है. That's not communicable at present, but somehow it spreads within community. This disease actually is visible on the skin, and immediate COVID से वो पूरा जो है isolation हो जाता है subject का, जिसको खुद ना बस ये problem हो जाए. So what they wanted is a model that can help by taking samples from my mobile phone. वो screenshot ले उस disease उस problem lesion area का, और उसको भेज दे सर्वर पे, और सर्वर से रिस्पॉन्स आ जाए कि आपको ये प्रॉब्लम है या कुछ और है. इज इट वाकई में लेप्रेसी और इज इट समथिंग एल्स? इफ इट्स समथिंग एल्स, it can be treated in different way, but if it's leprosy, it requires some different attention. So a person living in a village can just take that app, take a photograph, and get a basic initial diagnosis done, even in the absence of a doctor or medical practitioner there. So no need to do a detailed scan. So this is what they're planning. So you can see there itself, the model that they proposed, ChexNet they call it, and that was doing on an average way better than an average radiologist. Skin cancer detection, there also deep learning is getting applied. People collect skin samples. So one of the problem can be leprosy, one of the problem can be basic lesion on my skin, on somebody's skin, one of the problem can be skin cancer also. So you can take samples, the model can either do the calculation there itself on the phone, or it can send the data to the server, from there a result can come. So these kind of applications are quite very useful in the Indian scenario. Arrhythmia detection. Arrhythmia means problem with the rhythm of the heart. That detection can also be done by our neural networks. In fact, a smart watch taking regular heart rate can actually do that kind of a thing also. It keeps on taking the data, and after a certain interval from that data, it can be given to the server where the model is running, and that model can give you an analysis whether you are having some sort of an arrhythmia. So arrhythmia means without any reason acceleration of the heart rate. If it goes beyond a certain controllable value, the person tends to have a heart attack or arterial fibrillation. So you can see there also, after out of so many classes, the model was giving almost like 80% accuracy. Precision was quite high. 80% recall value, that is number of true positives, 82%, and FL score of 80%. And look, the best thing was that a cardiologist was giving actually the value of 74%. Which is why normally people say, अगर आपको कुछ problem है, medical problem है serious, so you always go for a second opinion. Why? Because it might have happened that somebody might have skipped something minute, something basic. We have heard of cases where people misdiagnose cancer and the person actually starts getting the cancer treatment, even though he or she did not require that. So they always say for any serious illness, before starting a thorough treatment, you should always go for a second opinion. So the reason being, we can do those kind of errors can always happen. Now, things are not just on software, things have started to change on hardware also. Google has recently produced this augmented reality microscope for cancer detection. Now, this is not a normal microscope. This microscope has that same glass thing where you can see those minute structures, but this microscope had something better. Can you see the demarcation done by the microscope? Can you see these demarcations? So this microscope is not just showing you magnified form of these samples. It's actually demarcating the problem where the problem lies. So if you look closely in this device, it's a simple machine here that's taking samples, but at the back end it has a computing machine where the computation is happening. And this machine has already been trained on millions of samples of the underlying disease, and based on that training, just like a doctor, it demarcates the problem to hai, kahan par hai, this is the problem. So it's actually assisting heavily the medical practitioner in taking decisions. It's demarcating the problem where the problem lies. So this was shown for lymphoma cancer. This was also shown for prostate cancer. So if things are so bright where the problem lies, I mean, why aren't we doing something at a tremendous rate in general? So ML should be used as a tool like statistics, right? This should not be a complementary, this should not be a competitive thing. This should rather be a. कई दफा लोग इस बात से घबरा जाते हैं कि यार ये तो हमारी नौकरी ले जाएगा या फिर this will start penetrating into our profession. So let's take it like a kind of complementary thing. This is something like computers came to India. People had that issue. A lot of jobs maybe will be taken away, but nobody realized that today because of computer itself, we've got a lot of jobs that are being created. Obviously, some kind of jobs they suffer, but a lot of jobs they tend to get generated. It all depends upon how smartly you catch on to the idea. A problem that deep learning models tend to face in medical data is the data set problem itself. I mean, thank God, let's be really thankful. Other than these epidemics like COVID and other things, largely the diseases have a very similar kind of a pattern that they affect a very small population. Right? That population is about like 1% or 2%, not beyond that. जैसे वो 8-10% को जाता है हम तो उसे epidemic कहते थे. So because the samples, the cancer samples, let's talk about the cancer samples. The people suffering from cancer as compared to the entire population of a nation are very minuscule. They are very minimum, right? But the people who are not suffering from that disease, they are quite large in number. So obviously, if I'm trying to collect the data, the healthy person data will be outnumbering the number of cancer data. Right? Because my model is going to train on the data itself, and I'm not giving the model. For example, I'm saying that for addition, I will give you 1,000 problems, but for factorization, I will only do 10 problems with you. In which topic will you improve? In addition, right? In difficult addition, you will do better because the number of problems that have been done with you are quite large. Factorization की मैंने आपसे सिर्फ 10 प्रॉब्लम करी है वैसे, तो आप factorization उतना अच्छा नहीं करो. The more you practice for a class, the better you become. तो हमारे पास डिजीज वाली जो क्लासेस हैं उसके सैंपल्स बहुत कम मिलते हैं. ये अच्छी बात भी है ह्यूमन पॉपुलेशन के हिसाब से, लेकिन ये डायग्नोसिस के हिसाब से खराब बात नहीं है। तो अनबैलेंस क्लासेस होना सबसे बड़ी प्रॉब्लम है। इमेजिन कीजिए आपके पास एक डेटा सेट है, उसमें आपके पास 100 samples, you've got 100 samples. Out of those samples, only 10 samples are from the people who are affected by that disease. 990 samples are from the ones who are healthy. If you are making mistake for all those 10 people who are suffering from a problem, and rest 990 का आप बिल्कुल सही क्लासिफिकेशन कर रहे हैं, आपका मॉडल 99% एक्यूरेसी देगा। The model will give how many accuracy? 99%. Even though आप एक भी बीमार आदमी को डिटेक्ट नहीं कर पा रहे हो, आपके पास 10 बीमार आदमी का डेटा था, आप उन सब के लिए गलत डिसीजन दे रहे हो। आपके पास 990 सैंपल्स से सही है हेल्दी लोगों के, बट फॉर देम यू आर गिविंग रिजल्ट्स 100%। तो आप अगर उन सभी सैंपल्स के अच्छा भी परफॉर्म करोगे, लेकिन आप डिजीज वालों को डिटेक्ट नहीं कर पाओगे, तो आपकी 99% एक्यूरेसी तो होगी, लेकिन आपका मॉडल बेकार हो जाएगा। कोविड के साथ में भी यही हुआ था कि जब इनिशियली कुछ टेस्ट किट्स आई थी, तो उनके ट्रू नेगेटिव फॉल्स नेगेटिव्स बहुत ज़्यादा थे कि उस आदमी को प्रॉब्लम नहीं भी है, तब भी वो किट क्या कह रही थी, नहीं आपको प्रॉब्लम नहीं, मतलब कोविड है, बट इवन देन द किट वो से नहीं आपको कोविड नहीं। उससे प्रॉब्लम क्या था? अ पर्सन हैविंग कोविड इज डिक्लेयर्ड टू बी फिट, और वो कह रहा था कम्युनिटी को घूमिए आराम से। दैट वाज अ बिग प्रॉब्लम। सो इस तरह की अगर प्रॉब्लम होगी तो हमारा मॉडल जो है वो सफर करेगा। इट्स अ कम्पल्सन प्रोसेस टू क्रिएट डेटा। कौन डेटा क्रिएट करेगा? डॉक्टर्स ट्रीट करेंगे, डेटा क्रिएट करेंगे। दैट्स अ वेरी बिग प्रॉब्लम। So that is another hurdle that we normally face. Experts always don't agree. एक डॉक्टर कह रहा है इसको प्रॉब्लम है, on the basis of that अगला डॉक्टर कह रहा है नहीं प्रॉब्लम ही नहीं है। The other person is not so well trained. मेरे पास का 30 साल एक्सपीरियंस है। As per my experience, don't have that problem. Don't worry. Somebody says शुगर 110 भी हो गया तो भी आपको शुगर नहीं। Somebody says कि आपको 99 से ऊपर अगर शुगर वैल्यू जा रही है तो आपको शुगर है। Start taking medication. Every doctor has a different viewpoint. And that's also another issue while creating that data. As I said, variability of data. For the same disease, I can do a detection on the basis of different type of samples. Cancer detection can be done through physiological samples. Same is the case with COVID. COVID के लिए आप अपना ब्लड काउंट से भी चेक कर सकते हैं। COVID में आप एक्सरे करा लीजिए, COVID में आप सीटी स्कैन करा लीजिए। इन तीनों चारों तरीके से आपको मालूम चल सकता है कि आपको कोविड है। There are various ways of detecting a disease. So आपके लिए कौन सा भी अच्छा है, that is another again a problem. A lot of uncertainty is there and data sources का बहुत बड़ा problem. Just to share with you, this is a small collection of those repositories जहाँ पर आपको data मिल सकता है, image data मिल सकता है for various diseases. There is a very famous source, cancerimagingarchives.net. यहाँ पर बहुत different type of cancers के बहुत large scale data sets available हैं, जो कि already कई doctors ने annotate किए। Kaggle, I am sure most of you must have heard about this. It's a website that hosts competition. Data science competition, and you will find many diseases, even data sets over here. Skin disease, medical image analysis disease. How much time do we have left? Okay. 10 minutes are thank you. Okay, so I just rushed through a small work that we did that was for breast cancer detection. And this problem is a multi-class classification. This is a binary class classification also. So a lot of data set batch 2018. It's a data set that has multi-class classification. We have binary class classification samples also. So we did a couple of those model developments. This was one of the papers that we my research students they tried. And we got significant results here. I think this can skip. Okay, let me come to the part that I think is more relevant because you people. So I come to this website once again. This is called Teachable Machines, and you should be aware of this. Teachable Machine is a Google product. This website is very simple. You just need to log on to Teachable Machines. Simply type this on Google, Teachable Machine. You will get this web page. Okay, just click. No need to create any account or anything. Just get started. It will say that what kind of project do you want to build? Image project, audio project, or post project. So I personally wanted to do an image-based project. So it's actually asking me to tell the classes that you want to detect. So let's say I want to work on
So this is a small project I made on teachable machine. As you can see over here, 3 classes I made. The first class is bacterial infection. This is a chest X-ray image sample that I have created over here. Bacterial infection, this is how the chest X-ray looks like. I can click on one of them. This is how the chest X-ray looks like for bacterial infection. If I compare this with normal, you can see this is a normal, no ground glass. ये पिसे हुए कांच के जैसा एक बादल दिखाई देता है अगर आपको निमोनिया है, इसको मेडिकल साइंस में ग्राउंड ग्लास कहा जाता है. We don't find any such ground glass symbols over here. This is a normal class. तो मैंने यहाँ पर 3 क्लासेस बनाई है, बैक्टीरियल इन्फेक्शन, कोविड इन्फेक्शन, नॉर्मल चेस्ट एक्सरे. इन सैंपल्स के अंदर कोई भी ग्राउंड ग्लास स्पेसिफिकेशन नहीं है. सो दिस इज
data set which I have taken from is this. Just want to show you something here.
Okay, here are the classes. The first class is bacteria, second one is COVID, next one is healthy. And these are the samples. So these are already known samples of bacterial infection in the chest. So this is one data set. I've got many data sets listed over here. So 4-5 data sets of chest X-ray I have with me. Just want to show you something. So 399 images I've selected for bacterial infection. About 292 images for COVID infection. These are the X-rays of known COVID subjects. And the last one is normal chest X-rays of healthy subjects. Now I've done a training of my model, and is an SIRM COVID data set. It was collected by a center, SIRM, and these are the images of COVID subject. Now this is the same sample, okay, COVID chest X-ray sample, but this is not from the same data set. So जिन samples पे मैंने model को train किया है, ये वो samples नहीं है, ये different data set. So I'm just selecting one of the images from here, and see this image is given. क्लास प्रेडिक्ट करिए मॉडल ने वो कोविड करी. दिस इज व्हाट आई वांट टू शो यू कि जिस डेटा सेट पर मॉडल को ट्रेन किया गया था, इवन इफ आई गिव an image from a different data set, this model is still saying. So it's like training a model on Chinese data set, let's say subjects from China, and then testing the data set on people from India or Europe. The model is doing fine, which shows the robustness of the model. This is predicting COVID for those.
Let me take another sample. Last exercise, any other data set maybe. So normal, that means a
Healthy subject.
it has some
Sort of ground glass. So you can see the model
over here is having some sort of confusion between a bacterial infection and a normal. It's definitely outrightly rejecting COVID scenario in this image. It's saying that मुझे कुछ bacterial infection जैसा लग रहा है, maybe initial stage, लेकिन इसमें कोविड वाले सिम्टम तो बिल्कुल भी नहीं. तो दैट इज वेरी मच क्लियर. तो मॉडल बहुत ही कम सैंपल्स के बावजूद डिटेक्ट कर पा रहा है कि इस सब्जेक्ट को प्रॉब्लम है. ऑन अनदर इमेज फ्रॉम द सेम सैंपल इज saying I'm 100% sure this subject does not have any problem, either bacterial infection nor a COVID infection. This model is not a doctor, it's not a radiologist, but it's getting trained or getting actually assisted by the results stored by some radiologist and doing something similar process. So just where it can be useful in Indian scenario. Somebody has, let's say, gone to a local hospital in, let's say, a remote area. X-ray तो मिल गया, but वहाँ पर analysis नहीं हो पा रहा है proper. So if you have an app that can just take that screenshot of your X-ray and can upload it to a server, that server where the model is running can give you a result that this person has this problem. So if it has, relevant authorities can be alerted so that the person can be escorted, can be helped, or if it's not, then some other treatment can be done. So in Indian perspective, these kind of applications have a lot of scope where we can think about some model getting prepared for those kind of sections. And teachable machine is a very, very fun way to learn. I mean, I just made a model within those 5 minutes by collecting samples from my own webcam. So you can think about those scenarios also. I think that's it from my side. I had those 10 minutes. I hope that I've not exceeded my time. I tried to communicate with you those points which I think are relevant. This is a kind of, because you people are from CS, IT background, और आप लोग यकीन जानिए इस चीज़ का फ्यूचर अल्टीमेटली यही होगा. आज की डेट में एवरीवेयर कंप्यूटर्स आते हैं और यही एरा रिपीट करेगा फॉर AI. Every domain, whether it's directly connected to CS or indirectly connected to CS, AI will be there, or AI में खास तौर पे deep learning models and machine learning models will be there. So you should be sound about these. You should be well known about these. How many of you heard about ChatGPT? Lot, right? So how? Is it good or bad? Huh? It's good. How many of you think it's having some problem? I mean, it's a problem for humanity. Why?
Up to date.
Huh? Not updated. That's not a problem. It will get updated very soon. Friend, what's happening now? It's a challenge for you students. The rate at which you are learning and the rate at which these models are learning, they're incomparable. They're incomparable. We are doing like 5 subjects a semester, right? And this model can learn 5,000 things a day. So, incomparable speed. So we need to buckle up. If you're thinking yourself to be code builders in the future, forget about that. Forget about that. These LLMs, large scale language models, they can generate beautiful codes for language that you've never even heard of. So अपने आप को अगर आप कोडर की तरह सोच रहे हैं कि मैं किसी इंडस्ट्री में जाके कोडिंग करूंगा, तो उसका फ्यूचर बहुत जल्दी खत्म होने वाला है. आप लोग आर्किटेक्चरल डिजाइनर्स के बारे में सोचिए. ये जो न्यूरल नेटवर्क आर्किटेक्चर्स थे, उनकी डिमांड रहेगी, राइट? इंजीनियर्स में और कोडर्स में फर्क जो होगा वहीं पर आएगा कि यू शुड बी प्रॉब्लम सॉल्वर, यू शुड बी डिजाइनर्स ऑफ सॉल्यूशंस. अपने आप को एंड पर्सपेक्टिव में मत देखिए कि हम कोडर की तरह अपने आप को एक प्रॉब्लम आएगी. कोड होना बहुत जल्दी बंद होने वाला है. Because these languages, they will be doing, these LLMs, they're going to do tremendously well against us. आप कितना टाइम लेंगे पाइथन सीखने में? बहुत टाइम लगेगा. एक मास्टरी हासिल करने में आपको कई साल लगेंगे. और ये मॉडल्स कुछ ही साल से शुरू हुए हैं और पाइथन क्या और सिस्को की प्रोग्रामिंग क्या, they can do a lot. So it's actually a time for us to buckle up, not to lose in ourselves. And the speed at which we are learning each day, we need to be very, very well aware about ourselves. हम कितना सीख रहे हैं दिन में? Each hour, we must be taking up something. We must be learning up something. Hoping a very good future for everyone. Thank you for having me over there. So don't need to be afraid, but time to retrospect and think about ourselves deeply.
Thank you, sir, for such an enriching session and your inspiring words and insights on the world of AI, deep learning model frameworks with real-life examples and applications in healthcare, which has left an indelible mark on our hearts and has resonated in our hearts. Your eloquence today has served to the least for all of us here. Thank you, sir, once again. In the recognition of your exceptional expertise